Hi everyone. Now I am going to discuss about the friction. First of all, what is a frictional force? Frictional force is nothing but the force which opposes the relative motion between two surfaces. Two surfaces which are in contact each other. Okay. Now you can see if I take any body of mass m, if body is moving, forward direction is there. If surface is rough, frictional force will act backward direction. Now let us consider the another situation. There is a plank. There is a plank. On this plank, a body of mass m is placed here. Okay. Let us consider the plank is moving with velocity v, block also moving velocity v. Then friction, actually we can see that there is no relative motion. There is no relative motion. Now no friction. Okay. Now you can see that other cases. Let us consider that there is a plank. Plank is moving with velocity v. Now if I place any object m here, if whole system is moving, we can observe that the frictional force, whatever friction is there, if m is at rest with respect to plank, then to maintain that one friction will be there, no, friction acts forward direction on small m. Friction act forward direction on small m. Okay. In different cases, we can see that suppose a person is walking here. Person is walking on a road. In that case, we can see that the friction is supporting the friction is supporting the motion. Okay, friction support the motion. Support the motion here. What I am telling is friction will not oppose the motion of the body. Friction opposes the relative motion between the two surfaces. As a whole, you can write it as direction of frictional force is opposite to relative velocity. So I can write it as f cap is equal to negative of v relative cap. This is the direction of frictional force. Okay. Now there are the different kind of frictions are there. One is static friction, other one is kinetic friction, and we are going to discuss about the limiting value also. Okay. Now I am writing that there is a body of mass m is located. Now we are going to see that if this is a rough surface, I have applied a force. Let us consider the force applied on the object is F. Then we can see the frictional force is, in this case, body is ready to move forward direction. So now you can see the friction will be acting backward direction on the body. So you can see that minimum force required to set the body into motion. Is to set the body into motion is limiting friction. Limiting friction. That limiting friction value you can write always mu s into n. Now you can see in this case normal reaction is upward direction, mg is downward direction, where mu s is coefficient of static friction. N is a normal reaction. Okay. Now we are going to see that different kind of frictions. If applied force is less than that limiting value, what will happen? If applied force is greater than the limiting value, what will happen? We are going to see now. First, static friction. What is the meaning of static friction? Static friction is Fs. When force is applied on object. If there is no relative motion, between surfaces, the friction exists is static. That static friction you can see here, a body I have taken here M, I have applied a force F, still body is at rest. Okay, now to write the compensate this force, there will be some friction will be acting on the opposite direction, that we can write Fs is equal to F always. Fs is equal to F. Frictional force value is this, otherwise just you write that Fs is equal to F here. Fs value is equal to the F applied force only every time. Okay. Next one, kinetic friction. Kinetic friction Fk. When there is a relative motion between surfaces which are in contact. The friction exists is kinetic friction. Now in this case you can write it as a body of mass m is there. A body is already moving like this. In that case, relative motion can be observed, that is Fk. Frictional force is acting is Fk. That Fk value is mu k into n. We can write n is upward direction, mg is downward direction. We can write the Fk is nothing but coefficient of kinetic friction. Coefficient of kinetic friction. Okay, mu value, mu depends on the nature of surfaces. How roughness is there and how smooth is there, based on that it depends. Mu depends on nature of the surfaces, and we can say that mu s is greater than mu k. Coefficient of static friction value is there, no, that is greater than the mu k. Okay. Now these are the relations we can see, mu k into n, Fs is equal to how much? F. Now by using these relations, I am going to do the some models, that how these limiting friction, kinetic friction, static friction, when to take and how to proceed this. For example, I am taking like a body is 10 kg. I have applied a force F and mu s is equal to 0.4 I am taking. Mu k value is I am taking as a 0.3. Now I am writing the different cases now. If F is equal to 0 is there, then we can write it as body is actually not moving. body will not move. Nature of friction will be static. Nature of friction will be static. And static friction value also 0. It is not moving actually. No friction also you can say. Now, to what force actually you have to apply? Minimum force to set the body into motion. So calculate FL value. FL is equal to, you can write mu s into n. As per the question, you can see that normal reaction n is upward direction. G value is 100 is there. So you can write it as a normal reaction is equal to 100. Substitute there 0.4 into 100 if you rate that 40 newtons. From this we can say that if F applied force is less than limiting friction, then there is no relative motion, body is at rest, and acceleration of the body is 0. Next, and static friction value is equal to, we can write it as capital F, applied value. If F is greater than limiting friction, then body will accelerate. That acceleration A can be written as F minus Fk divided by the mass m. And what is Fk value? We can say Fk value can be written as mu k into n. Mu k value is 0.3 into 100. We can get the 30 newtons is the value. Okay, this is the values of this Fk value is equal to much? 30 newtons can be written. Okay, these are the relations we can see whenever a body is moving. Okay, now I will take the another relation. What is happening here? If F is equal to 10 Newton is there. If F is equal to 10 Newton is nothing but we can say 10 kg body. F is equal to 10 Newton is applied. So body is at rest. If body is at rest, Fs value also much 10 Newtons only. Acceleration value 0. Next one. If F is equal to, I am taking like a 50 Newtons. If F is equal to 50 Newtons, I can say that 10 kg body is there, and applied force F is equal to 50 Newton is there, and here F is greater than the limiting friction, so kinetic friction value will be existing here. Already I have calculated, that is 30, so acceleration is A. So I can write A is equal to, we can write 50 minus 30 whole divided by the 10. So we can get the 20 by 10 is equal to 2 meter per second square. This is my acceleration. Okay. Now if I draw the diagram between the static whatever frictional force and applied force. Friction and applied force. Whenever F is 0, static friction value also much 0 will be there. It will be increasing some value. Suppose say this is increasing to the what value it is increasing up to 40 newtons. FL is equal to 40 Newton. This is also called maximum value of static friction. Up to this point, proportional symbol can be observed. We can observe that graph is a straight line and proportionality symbol is there. Now suddenly you can see that it will come to the value of 30. So this is Fk value is equal to much 30 Newton. Whenever body is moving, no, you can say that kinetic friction value is remains constant. Okay, this is about the how static friction and kinetic frictions are existing. Some other examples you can see. A body of mass m is there, initially moving with a velocity v0. Okay, it is a rough surface. Let us consider the coefficient of kinetic friction is mu k. So now what time it will come to rest? At what time body comes to rest? At what time body comes to rest? V is equal to, you can write v0 plus a into t. What is the acceleration on the body? You can see that as the body is going forward direction, there will be frictional force. That frictional force is mu into n. As normal reaction upward direction and mg is downward direction, you can write mu into mg is the value. Now you can say that F is equal to minus m into a. We can write mu into mg value is equal to minus m into a. So a value can be written as minus mu into g. Minus mu into g. You substitute the a is equal to minus mu into mg. we can get the final velocity is 0, v naught minus mu g into t. Finally you can get the t is equal to v naught divided by the mu g. At this time body comes to rest. Now if you want to calculate what maximum distance it covers, what maximum distance body covers before it stop, now you know that v square minus u square is equal to 2 into a into x is there. v0 v naught square we can write minus 2 into mu g into x maximum value. So finally you can get the x maximum value is equal to much, v naught square divided by the 2 into mu g. This is the maximum distance covered by the body before it comes to rest. Okay, now we'll see that what is the limiting friction. Not limiting, what is the angle of friction? Lambda. Angle of friction is nothing but you can see when a body of mass m is placed on any horizontal surface like this, any horizontal surface or any surface. If I place any body of mass m like this, we can see there will be forces. Normal reaction is acting upward direction, and I am applying a force. Applied force is F is like this, applied. Okay, I have applied, this is variable applied force I have given. In that case I can see that the frictional force will be right side will be there. Okay, now if I see that what is the mg value is acting downward direction, the resultant contact force is there. Now I am writing like this, R is a resultant contact force. Now you can see there will be some angle theta will be there between the resultant contact force and with the normal force. Now you can see resultant contact force R can be written as under root of n square plus f square. This is my R value. Now I am going to write that what is the meaning of this. As f increases, we can say that my static friction also increases. Static friction is increases when body is at rest. Still body is at rest. I am writing when body is at rest. F increases, Fs also increases. In that case I can write R is equal to under root of n square plus f square you can write. Why? Because Fs is equal to F only. This is my resultant contact force. Now when body is about to move, we can say that Fs value is equal to much mu s into n. Then resultant contact force can be written as under root of n square plus mu s square into n square. Then we can write it as n is taken common, 1 plus mu s square under root. This is my resultant contact force. And whatever angle it is making, now we can see that tan theta, that theta value I am taking, theta is equal to much lambda. That lambda value I am writing. Tan lambda can be written as opposite side f divided by the adjacent side n we can write. So you can write it as mu s into n divided by the n. Now n and n get cancelled. Finally we will get the s. So you can say lambda is equal to tan inverse of mu s. This is the angle of friction. Angle of friction, we can say that the angle made by resultant contact force with normal force when body is about to move. Okay, that is called is called angle of friction. Angle of friction, lambda. Now, if whatever the force is applied, if force is there, F is greater than limiting friction. In that case, we can say that R value can be written as under root of n square plus Fk square. We can write under root of n square plus mu k square into n square. We can write. So R can be written as n into under root of 1 plus mu k square value. You will write. This is a value of R. You can see that as per the question, as theta increases, theta is increased from 0 degrees to the slowly increasing from 0 degrees to the 90 degrees. Tan theta value also will increase. At particular angle, we can say that if lambda theta is less than lambda, body will be at rest. Static friction exists. If theta greater than lambda, body will slide. Kinetic friction exists. Okay. If theta is equal to lambda, limiting case, about to move. Observe this carefully. Next one, same thing I am going to write in terms of the inclined plane. For that, angle of repose. Angle of repose phi. Now what I am doing is, I just take the one inclined plane. So I am fixing the inclined plane at point A, and I have placed a body of mass m. Now you can see whenever body of mass m is there, slowly I am lifting my inclined plane. If I increase my inclined plane from here to here like this, slowly I am increasing my inclined plane like this. Whenever I am increasing, you can see my theta value also increases. At a particular angle, theta is equal to phi, we can say that my body of mass m is there now, it is ready to move. In that case, I am taking mu into mg sin phi is there, and the normal reaction is n is there, and I can write it as mg cos phi is downward direction, and my limiting friction value is there, that I am writing like a mu s into n. I can write that value, you can write it as mu s into mg into cos phi. It is ready to move. Ready to move. Whenever body is about to move, you can see that mu s into mg cos phi value is equal to mg into sin phi. So I can write it as tan phi. I can cancel this mg value and mg value. Tan phi value is equal to much mu s. So I can write phi is equal to tan inverse of mu s. This is my angle. You can observe that this is angle of repose. Angle of repose. I am writing situations here. If theta is whatever theta value is there, theta is less than mu s, body is at rest. Static friction is equal to much mg sin theta. Next, if theta value is greater than mu s, body slides. In that case, kinetic friction will exist. That value is mu k into n, mu k into mg into cos theta. You can write. This is my Fk. And reaction force also I am writing. Resultant contact force you can write as under root of n square plus f square. I can write. Okay, n square plus f square. F square value is fs square. You write fs square. In this case, earlier also, in this case I am writing first case r value is equal to much. Now second case, in the second case, and here first case. Okay, here second case, I am giving like a whatever contact force is there under root of n square plus fk square. I will write. This is my r square value, r value, and in first case what is the r value, you can check that. Okay. This is the angle of repose. Angle of repose means at what angle of inclination, body is about to move. That is called angle of repose. What is meaning of angle of repose? The angle of inclination at which body ready to slide is angle of repose. That is called angle of repose. You can check that angle of repose is angle of repose. Okay. Now we are going to discuss in different cases. Let us consider that a situation is like this. I am taking a body. I am taking an inclined plane. Two cases. Let us consider theta and theta. Body is actually moving, sliding down. And whenever it is sliding down, we can say that mg sine theta will be acting downward direction. Kinetic friction mu k into mg cos theta will be upward direction. Body is having acceleration a. In that case, we can write a is equal to, we can write it as g into sine theta minus mu k into cos theta. This is a value. Suppose if you want to calculate time taken, time to reach the bottommost point, time to reach bottommost point, initial velocity value is equal to 0. In that case, time t can be written as root over 2 into length divided by the a value we can write, and velocity at bottommost point. To calculate velocity, you can use the v is equal to much, root over 2 into a into l, right? Okay. The same manner, if I take the one more body m, which is moving like this, it is a rough surface. We can see that mg sine theta will be acting downward direction, and frictional force, whatever frictional force is there, Fk is equal to mu k into mg cos theta will be acting downward direction. So you can write the body will be retarding here. Okay, that retardation is equal to much. A is equal to minus of g into sine theta plus mu k into cos theta we can write. Okay, now time whenever the body stop. Okay, body stops after time t. The time t value I am writing. If the initial velocity is equal to v naught is there. If v naught is initial velocity, now we can write it as time t is equal to, we can write it as v naught divided by the acceleration we can write. So that we can write v naught divided by the g into sine theta plus mu k cos theta is there, no, that we can write. Maximum distance it travels before it stops. Maximum distance covered by the body before it stops. Before it stops, we can write it as S maximum value is equal to v naught square divided by the 2a. You can write that v naught square is v naught square only, 2 into g into sine theta plus mu k into cos theta you can write. These are on inclined plane. Now other cases also you can write. Suppose say a body is actually moving on a conveyor belt. If any body is moving on a conveyor belt, I am just writing that conveyor belt. Let us consider this is a conveyor belt. We can see that. Let us consider that the belt is moving forward direction. Moving with V. if I place any body, just I dropped a body of mass m is placed on belt. Now you can see there will be some frictional force will be there. V relative is like this V, then friction is acting in forward direction. Okay, you can use that when it will stop coming to rest and all. You can calculate by using the relation, general relation I have given now, that t is equal to velocity into time taken, v is equal to u plus ct, s is equal to v square minus v square is equal to x. By using that we can calculate the conveyor belt. Okay, kinetic friction will be acting forward direction. Okay, similarly you can see that some other things, like we'll see that on a rough surface, on vertical rough surface, I am taking a rough surface like this. Let us consider there is a body of mass m is placed and I have force is pushing force. Body is pushing like this. We can see body is having mg downward direction, and if it is rough we can say that frictional force will be upward direction. Now what are the nature of the frictional force here? Normal reaction will be opposite direction. F is equal to always equal to n here, and you will calculate F L is equal to mu s into n. We have to write. Let us consider the mu s value and let us consider the mu k value also. You will see that if driving force mg, driving force is mg. Okay, I'm writing driving force is mg. If mg is greater than limiting friction, then body slide down. In that case we can write the kinetic friction value, right? Kinetic friction value is mu k into n. Next, acceleration A can be written as mg minus fk divided by the m. Next, if mg is less than limiting friction, body will be at rest. If a body is at rest, we can write fs value is equal to much mg only. In that case, acceleration value is equal to much 0. Okay, you observe this, any vertical surfaces are given, we can follow these rules. Next one, block on block. Block on block problems. On block problems, you can observe that there is a body of mass capital M is placed here, and there is a small m also placed on this. Let us consider it is a smooth, and upper surfaces are there now, they are rough. If I apply the any force F here, first you need to calculate the what is the limiting value. Let us consider rough and coefficient of friction value is equal to, I am giving like a mu s and mu k values are given. Okay, now I am giving now first you have to calculate up to what force they are moving together. Okay, now I am calculating that to move together, how much force you need to apply. Okay, I am writing now. On body of mass m, we can see there will be limiting friction. That value is mu s into normal reaction. That value is mu s into mg will be there. Now this is the maximum acceleration value we can see. Now I am calculating what is the maximum acceleration to move together, or just I am writing acceleration. We can say that A is equal to mu s into g. Okay, move together, both blocks will have same acceleration. Now we can write it as net force F is equal to m plus m into acceleration A. We can write mu s into g into small m plus capital M. This is the force applied to move together. Okay, now I am giving that what are the conditions are there. If F is less than mu s into g m plus m, nature of friction is both blocks move together. Both blocks move together with the same acceleration. With the same acceleration, that A is equal to, you can write F divided by the small m plus capital M. This is a relation for this. Okay. Now you can write the different relations also. If you want to, you can check the relation on the lower block now. Capital M is there, capital F is acting. Fs means mu s into g is m is acting, acceleration upward direction. F minus mu s into mg is equal to m into a, you can write. Okay. F minus mu s into mg value is equal to m into mu s into g. So you can write F is equal to, you can write as mu s into g common. So m plus capital M is there. No? That also, if you want, we can proceed in this manner also on the lower block. Okay. But otherwise, you can write directly, they move with the same acceleration is there. No? That also you can write. Okay. Now I am checking that A is equal to much F divided by the m plus m. And static friction will be existing. No? That value is equal to small m into A. Okay. Next, if F is greater than mu s into g, small m plus capital M is there, then there will be relative motion between two blocks. If there is a relative motion between the two blocks, we can say that whatever kinetic friction exists now on upper block, you can see that small m kinetic friction will be acting forward direction, that is equal to mu k into mg. Acceleration A value will be there, that is A small m I am writing. A small m can be written as mu k into g, this value is constant. Okay. Next, on lower block, force is applied forward direction. Fk is acting like a mu k into mg forward direction. This body is moving with am. I am writing acceleration of the lower block is equal to F minus mu k into mg whole divided by the, you can write it as mu k mg, I am writing properly, mu k into mg whole divided by the capital M. It is variable with applied force F. So like this, we can calculate the kinetic friction value as well as acceleration of the upper block as well as acceleration of the lower block in case of the block on the block problems. First, you need to check the what is the common maximum velocity, maximum force we need to apply to move together. Okay, this force is there now. This force is what here? This is the force, maximum force. Maximum force for blocks to move together. Okay, after that blocks will not move together. Okay, this is the relation. Same thing you can apply for the upper block and lower block also, maybe any rough surface will be there. That also you can apply by using the general limiting cases only. Okay, I hope you have understanding this concept whatever I have given. You can solve the problems related to the friction. Okay, I have done the some problems. You can also solve the PYQs like a JEE mains, JEE advanced, all questions. Okay, I hope you got it. I will continue in the next video with the circular motion. Thank you very much.